Today we're going to go ahead and make an automatic electronic light control. Basically this consists of a photoresistor that when it senses light changes, it also changes its resistance. So the whole purpose of this is to create basically the same thing as what you would have in the garage when you, or a night light, theoretically a night light, that when the light goes out your LED comes on. So here we're going to go through a few things first and determine what makes this circuit work. LDR is considered the photoresistor right here. It's basically what I just explained. As the light changes, or as you place your hand over the photoresistor, it'll actually change its resistance to let in either more voltage or less voltage. Now these right here are connected to 12 volt. This is a 12 volt source and this is a 12 volt source. Sorry, actually I meant to write the 12 volt in here. 12 volt source. You can use the same 12 volt source for either one of these. They don't need to be negative, even though the op amp is an inverted op amp on the top and non-inverted on the bottom. The whole purpose of this is to do a voltage divider here between the two resistances, or the two resistors, sorry, and run this into the op amp, and then do the same on the bottom. And the slight change in the voltage when no light is on the photoresistor should produce no voltage going out of your op amp here to your diode. So basically all the components in this are photoresistor, a 12 kilo ohm resistor, a 1.8 kilo ohm resistor, a 1.2 kilo ohm resistor. These are both hooked into ground, the 12 kilo ohm and the 1.2. You have your op amp, which basically takes care of, it compares the two voltages and then gives you an output. You actually have to run, another portion that I kind of forgot was, you run a 12 volt source into the positive end, and you run 0 volts into the negative end to power your integrated circuit. Now right here is your 12 kilo ohm resistor that follows the output to help make sure that you regulate your voltage output to your transistor. The transistor here is a little bit more difficult. When you look at a transistor and you're holding one in your hand, which is actually this right here, when you hold it upside down, when you place it right side up, it's inverted. So you have to make sure you watch out for that, because the E and C here, which is kind of hard to tell, you have to make sure they go to the correct thing, because when you're trying to produce your output, you want the E to go to your LED and you want your C to go to ground. The purpose of that is to make it's a kind of a current regulator. First thing we'll go ahead and do is determine what our voltages at V1 and V2 are. For this to be necessary, you need to do the voltage divider rule, which is fairly simple. It equals Vin times the voltage that you're putting into the two resistors times the resistance of the second resistor over the sum of the two resistors. So we're going to say that the LDR of the photoresistor is going to be 2 kilo ohms. Since pitch black it'll be you'll have 2 kilo ohms going through that, so you'll have no voltage, or you'll have more voltage going through this. So